Well, welcome. And when I upload this, it'll be a new year, 2013. And just the other day, it snowed on Christmas Day, and that is pretty darn cool. I took a picture of it out in my backyard, and we had enough to even build a snowman. But with this, our vacation is coming to an end, and we have a test just right around the corner. So let's go ahead and do this. I'm going to do a series of videos, about 3 or 4 videos. None of them are going to be that short. But you can skip from example to example and just look at the specific examples you want to look at. So when you see a YouTube video with 10 or 12 or 15 minutes on it, don't fret like you have to watch the whole thing. Just skip to the video part that you want to go over. So let's take a look at our first example. Pythagorean. We know this. We're going to use the Pythagorean a squared plus b squared equals c squared because we have no clue on if this is a special right 30-60 or 45-45. Nothing tells us that it is that case. Plus is just set up for that. We're going to do a squared plus b squared equals c squared. But look at this. That is a binomial, x plus 7. We're going to have to square it, x plus 7 squared. So let's go ahead and set this up, and let's see if my handwriting's improved. It probably hasn't. My left arm is still questionable. I did see the doc actually today, and she's not sure if it's broken or not. The x-ray person was not in. So here we go. We have 5 squared plus 12 squared is equal to x plus 7 squared. So we know we have 25 plus 144 is equal to x squared plus 14x plus 49. Your algebra teacher, if it wasn't me, said FOIL it. I don't FOIL. I just use the distributive property. But this is a special polynomial. We can just use the shortcut on that. But all you do... And this is an algebra review. If you don't know your algebra, you better stay on top of it. It's just that you multiply this out. You start with first term, multiply it all the way through. Then you start with your second term, multiply it through. And if you had more, you just keep doing it. And this is what you get, x squared plus 14x plus 49. When we're solving a quadratic, we want to get everything to one side. So we're going to go ahead and do that. So we're going to subtract this 169 minus plus 49. And that's going to give us x squared plus 14x. You can do this in your calculator or whatever. 14x minus, because we're going to subtract this 169 right here from the 49, because we have to set our quadratics to 0, and that gives us 120. Negative 120 is equal to 0. Remember, when we solve our quadratics, we have to ax squared plus bx plus c is equal to 0. This is standard form. Well, what we're going to do on this test and on this preparation is, since we're not in an algebra class, I'm not going to make you do this by hand. We're going to do this on the calculator. So let's go over to the Casio right here and go ahead and do menu. Since we have it in standard form, we're going to go to equation right here. So I got to tab down to equation, hit enter. And I'm going to go to polynomial. This is exactly what we have. You can do it in the solver, but we want an exact answer. If there's anything in here, delete it. Oops, that's the delete button. Yes, we want to delete. So we're going to do second degree polynomial. I have a coefficient of 1 for my a, enter, 14 for my b, and negative 120 for my c. Hit the solve button. And we have x is equal to 6 and x is equal to negative 20. Well, we are going to have quadratics often give you two solutions. And one is going to be extraneous right here. This negative 20, we're not going to have a negative 20 here because that would not make sense. This can't be a negative length. Negative 13 meters or feet do not make sense. X is going to equal to 6. And that's exactly where we're at. We're going to write x is equal to 6. And this side is 13. I kind of already knew that going in because guess what? The 5, 12, 13, that's a Pythagorean triple. If you had recognized this as a Pythagorean triple, you just set x plus 7 is equal to 13 and solve for x. Next one, not so straightforward. This one's a little bit nastier. Here's my a squared, b squared, and c squared. Let's go ahead and set it up. X plus 7, this one is kind of out of the book. It was a little bit different than the one I got out of the book. X squared is equal to 21 squared. And what we're going to do, we're just going to go ahead and start simplifying this a little bit. So we got x plus 7 squared. I've already polynomialed it out for you right up here. So we know what it's going to be. So it's going to be x squared plus 14x plus 49, a little bit of bleeding, plus another x squared is equal to 441. And I have my perfect squares memorized, at least on every other day I do. But you can always use the calculator right over here. It's not a big deal. Combine like terms. So we got 2x squared plus 14x plus 49 is equal to 441. And I'm going to subtract 441 on both sides. And that gives me 392. Use your calculator, guys. Plus 14x minus 392 is equal to 0. Standard form. Now, my math is done. I'm going to go up here and do repeat. I'm going to delete whatever's in here. Delete all my coefficients. Second degree quadratic. A is 2. Enter. B is 14. Enter. And C is a negative 392. Enter. Solve. And here it is. I have two solutions. Throw out the extraneous one. We're not going to have a negative side here. We can't have negative 17.93. But if it says exact in the instructions, this is rounded right here. My exact is negative 7 plus 7 radical 17 all over 2. That's the plus one. If I were to scroll down here, watch. There's my minus one right over here. That would be this one right here. We're taking only the solution that works. In algebra, we wanted two solutions. Geometry, we want to toss out any extraneous solutions. Example number 2. Oh, that was 2. Let's go to example number 3. What do I got here? Oh, this one's straightforward. This is a skill, but this is just an algebra skill. We're reviewing it in geometry because we do a lot of this, especially in our quadrilaterals and triangles. So we're just going to add and subtract radicals. Just like in fractions, we have to boil them down to their basics. So right here, we're going to simplify this radical 18. I taught you the method of the perfect square method. Biggest perfect square that goes into 18 is 9 times 2. Plus, I'm going to write it all out for you. And the biggest one here is 4 times 2. Minus radical, and the biggest one here is 4 times 6. All right. So, square root of 9 is 3. That comes flying out. Smacks right into this negative 3. So I got a negative 9. Negative 9 radical 2. That's a 2 flying out. Hits that 3. That becomes a 6. We multiply. 6 radical 2. That becomes a 2. Hits that negative 1. So we have a negative 2 over 6. Combine like terms. Boom and boom. That gives me a negative 3 radical 2 minus 2 radical 6. So let's take a look at this on the calculator real quick. So I'm going to go to menu, go up to run matrix, which is my 1, and I'm going to put in the original problem, just the way I see it, exactly the way I see it. Negative 3 shift radical 18. I have to tab over because it'll carry the radical sign with it, plus 3 shift radical 8, tab over, minus radical 24. Hit the enter button. And it looks like I have the same answer, just, they used the commutative thing going on. So they just flip-flop places. Now, as I've said, calculators are a great tool. And I bet you in your algebra class, they're not going to let you use these Casios on a lot of your assessments because in every job interview I've given and I've gone under, no one ever asked me how well I can push buttons. They asked me how well I can think, in various ways, that is. And we train, the reason you're studying math is not to get right answers and not to solve problems that you're never going to see again in your life, but it's to practice your thinking ability. So, yes, it's all well and good. You can put this in the calculator, and you get to use the calculator on this test, and yippee-yay, you're going to get a right problem, 4 or 6 problems, 4 and 6 points free. But just realize we're trying to exercise your brain. So this is what I want you to be good at. This is all well and good. Moving on. Okay, I gave this to my algebra students last year, and an algebra student will approach it like this. So let's take this. we have a right triangle. Don't know what kind of angles are. An algebra student wouldn't care what kind of angles are. They just know it's a right angle. So it's a right triangle. But they do recognize this. This and this are the same. They don't know what this length is, and in algebra we would call that x. Well, if this is the same, that's also x. And guess what? An algebra student will go like this. X squared plus x squared is equal to 40 squared. And that's just 2x squared is equal to 1600. X squared is equal to 800. Did you see that? I just divided by 2. And then x would equal to the square root of 800, whatever that is. That would hurt my brain, so I would just go over here and shift. Boom, 800. And plop that in there, and hey, I hit execute. Yeah, 20 radical 2. X is equal to 20 radical 2. That's a algebra student. You guys, geometry, we'll do this in green, should recognize this as an isosceles. Base angles are congruent. So these are congruent and these are 45. So we have a 45-45 right triangle, which means that given this side here, we know that if this is x and this is x, or actually let's write a's here. This is a, this is a, this is a radical 2. So all you do is just set 40 is equal to a radical 2 to find your missing side. You have a is equal to 40 over radical 2. No radicals in the denominator. And you would have 40 radical 2 over 2, which is 20 radical 2. That's geometry. And this is algebra. Okay. Alrighty. So that wraps it up for this one. And I will get all these videos uploaded probably before the weekend that school starts. Alrighty. We will start on the next one shortly.